All right, this is probably going to be my last video on the Cadac module until I rack it. Um, so what I have gotten into on this guy at this point, I fixed my 7-segment display. This PCB actually took a nasty hit, and all the connectors for this are like right on the edge of the PCB, and so I just bridged those with some wires. You can see one of those poking up there. So I've kind of gotten all the issues figured out. I'm replacing the pot here that had the broken shaft. So I'm waiting on that to get here. But the subject of this video is going to be this little guy here. This is a seed with 3 E's, Xiao, X-I-A-O. It is an Arduino IDE compatible microcontroller. And what I wanted to do with this is this console came with a constant control module, or CCM, that was responsible for writing the automation, the fader automation. And obviously I don't have that. So I thought, well, I could do something with the functionality of this motorized fader. And so I own a Midas M32R, and that thing, with the main fader, upon power up, it actually drags it down to 0. So I decided to do that with this guy, and I'll go ahead and hit the power on this just to demonstrate that the pot hanging out there. So let's turn it on. And I put so there's the 7-segment, and boom. So I'll go ahead and demonstrate what that looks like on the Midas. Okay, we're here at the Midas. I'm gonna go ahead and hit my master power switch here. So kill the power. Let's turn it back on. So the main fader all the way to the right here is it's gonna zero itself, or null itself rather. 0 would be 0 dB. Yep, there you go. So it does that. And so really the way I accomplished this op amp right here is configured like an H-bridge kind of deal. If you look at the data sheet for it, it actually is, it's a L272, and it's like it's meant for driving bidirectional DC motors. It's not wired up like the data sheet, like the, typically on a data sheet, they have like example circuits. It's not wired up like that. So a little bit different, and also it's actually driving a solid state relay that is, in the relay, the solid state relay is actually controlling the voltage or the current to the DC motor. So what I did is I just pulled out that pin on the solid state relay. This is like the LED anode. LED anode. And I just soldered on tacked on a resistor here, 100 ohm resistor. This is a 3.3 volt circuit. It's running off 5 volts, but the whole thing operates off 3.3 volts. So wired that to here, just did a digital high right on this pin, and then I used another solid state relay. It's basically like it's acting like a comparator between these two. It's inverting and non-inverting input. It's dual op amp. This is inverting or non-inverting, and then this is inverting. And basically, if you short one of these to ground, it'll just pull the motor in one direction, like all one direction. It'll either go all this way or all this way. So for the sake of this project and the purpose of it, I did it in one direction. Now I have the option here. I left myself open to put another solid state relay. This is actually like basically the same thing. It's G3VM. This is just like an older version, 6-pin. I think it only uses 5, and I'm not sure what the middle pin does. I'd have to go back and check the data sheet. Anyway, I've got a bunch of these from another project I tried to do that I didn't. I tried to use audio through them, and MOSFET relays do not work well for audio isolation. So anyway, for logic, though, they're great. So what I did was I left myself open. If I do want to program something, maybe I could have it pull it to 0 or something like that. I don't know. But what's cool is I could actually control both modules. Since I've got 2 modules, I could control both of them with this one little microcontroller. So I just got to do a little bit of cleanup work there. But yeah, I just figured I'd kind of demo what I did here. And maybe it would spark some usage case ideas for you guys if you happen to get a module that has a motorized fader. So in this case, I just thought it was kind of cool for it to just zero itself out or null itself out on power up. It's 11 lines of code that I did. It's basically just it's doing a digital write, a delay, or actually it's doing a delay and then a digital write high, a short delay and then another digital write, and then another delay, and then it just writes them both low, and that's it. So, and you can see when it releases itself from the timing that I did on here. So let's pop it back up here, turn off the circuit. You'll see it'll release itself once it hits here. A little click released itself. So anyway, that's that.